Welcome my dear student. So in this video series, I am going to solve some of the interesting and challenging problems from the book Problems in General Physics written by Irodov. So let us start with the solution. So there is a small ball M is fitted on one end of the thread and on the other end there is another rod of mass capital M is there. In the situation it is given that the capital M is more than the small m. So capital M value is greater than small m. Now, initially the system is released from rest and ultimately what happens? So you are asked to calculate the friction force. So friction is acting between the ball and the thread and because of that the ball is moving upward. Ultimately, after t second of time, the ball comes to that position. Okay. So the length of the rod is given as L. So length of the rod is given as L. You are asked to calculate the friction force between the ball and the thread. Okay. So in this situation, what is happening that the ball is not tied with the string. Ball is not tied with the string. That means it is not affected with any kind of tension. So only thing is that on that ball, the friction is acting upward. The friction force. And similarly, on the other end of the rod, there is also another friction force is acting. Okay, there is no tension force. Because of this, both the capital M and the small m are moving downward with different acceleration. Let us say it is moving with an acceleration A2 downward. And it is moving with an acceleration A1 down. Okay, so if I do the force balance equation, so here the small mg will be there, here the capital mg will be there. Okay, so from that what we can write the A2 acceleration will be equals to how much? A2 of the rod is equals to capital mg minus fr divided by m. Similarly, A1 should be equal to how much? A1 should be equal to small mg minus fr by small m. So these are the two accelerations with which both the balls are moving downward. Okay, both the balls are moving downward. Now, in time t, let us say the small m crosses the capital M. So that means the ball is moving with a relative acceleration of A2 minus A1. If I assume the rod is at rest, so ball is moving with a relative acceleration of A2 minus A1. So A2 minus A1 should be how much? That should be equals to capital mg minus fr by capital M minus small mg minus fr by m. Okay, this is the number of A2 minus A1. Now with this A2 minus A1 in time t, the ball is crossing the length. So one equation that I am getting from the kinematics part. So L distance is traveled with an acceleration half into A2 minus A1 in time t. So half at square. Okay, so I can solve this equation to get the value of A2 minus A1 with respect to L. Now, in this question, you are asked to calculate the value of friction force. So, for that, I have to simplify this number. So, let us say A2 minus A1 is how much? A2 minus A1 is half into that number. So, G minus FR by capital M minus G plus FR by small m into T square. Okay. So, ultimately what happens? G cancels out. So, we are left with half into fr 1 by small m minus 1 by capital M into t square. Okay. So ultimately what we can write that the value of L equals to fr by 2 divided by capital M into small m and in the numerator capital M minus small m into t square. So that means fr should be how much? Fr should be equals to 2 times of capital M small m L divided by m minus small m into t square. So that will be your answer for the friction force. Okay. So in this situation what happens? Only the friction is coming into the picture, no tension because the ball is not tied properly with the string. So what is happening? There is a in between the ball there is a hole. So through this hole the string is passes. So that means the ball can slide with this string, with this hole. So no amount of part of the string is tied with the ball. So tension is not coming inside the ball. Only thing is that the ball can slide or move along this rope because the small hole passes to the center of the ball. Okay. So only thing that you have to consider only friction force. No tension is acting over here. Hope you understand this. Thanks for watching my video. If you like this, please subscribe my YouTube channel and also follow the upcoming videos on this topic also. Thanks for watching.